we are going to live, and Xavier, I will let you know when you can start through the chat, okay? Good luck, everyone.
Good morning to everyone, and welcome to this parallel session on water climate change challenges and solutions. My name is Xavier Bernat, the Technical Director of CETACUA, which is the Water Technology Center of Suez, Spain. And I have today the pleasure to be the chairman of this session. So just to be in the same framework for this session, through all the time we have, so through these 90 minutes, we will have 5 use cases of different regions around the globe that will be shared by our speakers. So we really wish that these 5 presentations will allow us understand the particular challenges and potential solutions that may face and reduce urban water services stress in these regions. Moreover, I also wish that the knowledge that we will share today during the session might serve to adapt it and apply it in other regions around the globe with similar conditions than the ones explained today. The 5 cities that will be the core of today's sessions are Pont-d'Omdin in northeast England, Benidorm in Spain, Asuncion in Paraguay, Barcelona in Spain, and some cities in the northeast region of Brazil. The dynamics of the session will be that each presentation will be given in around 10 minutes without time for questions and answers after each presentation. And for this, we will have a dedicated chapter at the end of the session of around 20 to 30 minutes for having global questions and answers to all the presenters. So please use the chat to pose your questions so that they can be compiled and distributed to the different speakers at the end of the session. So let's start by our first presentation that will be given by Mr. Ahilan. And the title of the presentation is Achieving Urban Water Supply and Flood Resilience Using Catchment Scale Rainwater Harvesting. And Mr. Ahilan works as research fellow at the University of Exeter. And Mr. Ahilan research interests include flood frequency analysis, floodplain hydraulics, sediment dynamics in green infrastructure, urban flood modeling, rainwater management, and urban metabolism modeling, among many other topics. So please, Mr. Ahilan, the floor is yours.
Good morning, all of you. My name is Sangaralingam Ahilan. I am based in University of Exeter. So this talk focuses on the potential of the catchment scale rainwater management on urban water supply and flood resilience. So I aim to touch upon briefly on the 3 points. First, introduce the difference between the rainwater harvesting to the rainwater management and present some of the potential of the catchment scale rainwater management on flood resilience, and then present some of the work what we are currently doing and some conclusions. So if you look at the typical rainwater harvesting, so if you look at the diagram on the right-hand side, so that's mainly focusing on the single benefit. So we are focusing on the water supply augmentation only. So if you consider the cost benefit analysis of that, it's fall into the area that's marked by the blue color polygon. So there's a relatively higher cost than the benefit we get from the typical rainwater harvesting. So on the other hand, if you include the other benefits such as the stormwater management potential of the rainwater harvesting system, so that's called here we call as a rainwater management system. So then we can push that boundary towards the origin, so we get the relatively more benefit rather than the cost. This allows to adaptation of the catchment scale rainwater management in urban scale. So in this presentation, I briefly present some of our work on the catchment scale rainwater management on the urban flood resilience and the water supply augmentation. So as I mentioned earlier, the rainwater harvesting is mainly focusing on the single function, and also it provides a single benefit, that's a water supply augmentation. Whereas the rainwater management, it provides, in addition to the water supply augmentation, it provides the stormwater control benefits. So we are moving from the rainwater harvesting towards the rainwater management system to get the relatively more benefit from the system, multiple benefit from the system. So this is our case study region. So this is on the northeast of England, the place called Newcastle upon Tyne. So there is a relatively highly urbanized city and also vulnerable for the pluvial flooding. So here we consider the typical house. These are the properties of the house. So that's for a household-based rainwater harvesting. And then we scale that up to the catchment scale rainwater harvesting system. So these are some of the attributes of the house we consider in the city. And here we consider the 3 types of the rainwater harvesting system. The first one is the single tank. So here we have a single tank that's equivalent to the water butts you may have it in your house. So it collects the runoff from the roof, and then if it's exceeded capacity, and it goes to the as overflow, and also part of the water is go to the non-potable water usage. In this case, is a toilet flushing. And the second system, we have some control in the middle. So then we regulate the flow through this control through the orifice, which is equivalent to the greenfield runoff rate. So that's a passive system. And also if it's exceeded, again, is similar way like previous one, is overflow. And also this control, the control flow goes to the sewer system. And the third one is a little bit more advanced. Here we have the control in the tank. For instance, if we know the tomorrow rainfall forecast, we can adjust the tank volume such a way to accommodate the tomorrow rainfall event through the Internet of Things. So that we can regulate the volume of the tank. So here we don't have any flow at the middle. Here again, single tank, but we can regulate the volume of tank as necessary. So this is one of the 2012 Newcastle Experience series of extreme rainfall events. This is the one of the extreme rainfall events here we model. So in the top part. It's a black color diagram, black color graph that shows the rainfall. On the bottom one is the flow. So here is the red means uncontrolled overflow. Here, if we don't have any rainwater harvesting system in place, all of the rainfall landed in the typical house, it's resulted as a quick runoff into the sewer system. So it's the bottom graph is a mirror of the top graph. Here we don't have any rainwater harvesting system. So if you look at this peak is quite high peak. So this result of the extreme rainfall event at this point. So it's extremely quite high peak as a result of the extreme rainfall event. So then if you place the type 1 rainwater harvesting system, then we can reduce certain portion of the uncontrolled overflow, but still there's a good amount of uncontrolled overflow because of the extreme rainfall event. Tank gets full. So then after that, when the water comes in from the roof runoff, is resulted as an uncontrolled overflow. So then when we consider the type 3 system, so this is the active system. So here we can considerably reduce the uncontrolled overflow because we can adjust the volume of the tank such a way to accommodate the extreme rainfall event. So if you know that tomorrow rainfall, we can empty the tank to accommodate that specific extreme rainfall event. So these are some of the simulation results. And then here we use the model called this cellular automata type flood model to model the impact of the rainwater management system on the flood resilience. So before we compare with some of the rainwater management system, apply that into the rainwater management system, we compare that our model, this is based on the cellular automata type flood model, with the hydrodynamic model, 2D hydrodynamic model, that's called the CityCat, which is developed by the Newcastle University. If you look at the right-hand diagram, top diagram, that's on the particular 20-year, 1 hour storm, that's from the CityCat model. And the bottom one, that shows the other model called CADIS. So that's a cellular automata type model. Then if you subtract from the CityCat simulation, from the CADIS simulation, if you subtract the CADIS simulation results from the CityCat. So here is the difference. As you can see, it provides reasonably good agreement with two-dimensional hydrodynamic model. So this is kind of model verification process we did in order to compare our simulation results to that gives some kind of confirmation that our simulation is working reasonably well. And then on the 20th June, as you can see, these are the simulation results. We get up to a 40 centimeter flood depth on the on certain part of the city. So this the flood route is this way. So it provides some of the area, and the university gets Newcastle University gets flooded from this incident. And then based on the traditional rainwater management, so what are the benefits we can get? So it's provide reasonably good reduction of the based on the traditional rainwater management. Also the passive system, and we have the control at the middle of the tank through the orifice, we can get this sort of reduction, and also the active system. So these are some of the simulation results, as I mentioned earlier. So we can get up to 80% of the water supply augmentation for this is for the toilet flushing, and also the reduction in the stormwater discharge reduction that's vary from 50% to 95% based on the which type of the system we use. And also for a maximum extreme rainfall events, if you use the active rainwater harvesting system, we can considerably reduce the peak up to 60%. So I quickly going to summarize. I hope I'm on the time. So I quickly going to summarize my key finding. Regardless of which rainwater management system we use, we get a certain level of water supply augmentation efficiency as well as the stormwater control efficiency. The passive and the active system, they are relatively efficient to control the stormwater management point of view. And also the other indirect benefits, such as if you control the uncontrolled overflow into the sewer system, we can reduce the pollution, the overflow from the combined sewer overflow, and also it's improve the resilience of the water supply system as well as the wastewater management system, because we can reduce the stress, additional stress on that wastewater system if you reduce the amount of water that's getting into the combined sewer overflow from the storm runoff. And the final point is the multifunctional, multi-benefit system, which are the future. So we need to focus more on the multifunctional and multi-benefit systems, such as the catchment scale rainwater management system. So that's including the water supply as well as the stormwater control potential. So I stop here, and then I take the question at the end of the session.
Thank you very much, Mr. Ahilan, for your clear presentation of your work. So as you said, we will leave the question and answers for the end of the session. So please, the audience, feel free to write down through the chat your questions and answers or desires that we can debate at the end of the session. So let's move to the second presenter of the session, which is Mr. Miguel Balaguer, talking about urban resilience diagnosis in the context of climate change in Benidorm, in Spain. So Mr. Balaguer is a Master of Science in Hydraulic Engineering and has almost 10 years of experience in water-related projects, particularly in asset management, metering, modeling water and sewer networks. He's currently participating in Suez Group in projects related to urban resilience and emergencies. So please, Mr. Balaguer, the floor is yours.
Thanks a lot, Xavier. Thank you to RESCCUE to organize this congress. My title presentation is Urban Resilience Diagnosis in Context of Climate Change in Benidorm, Spain. So let's start presentation. Let me see what happened here. Okay. So Benidorm is located in the east of Spain and has a privileged location of the shore of the Mediterranean Sea with a special microclimate with comfortable winters and summers. This clear advantage of location and climate transformed in the second half of the 20th century the urban structure of a fishing village with 3,000 inhabitants in the 50s, or in a city with 70,000 residents registered and more than 300,000 people in high season. Benidorm, as other cities located in the Mediterranean region, sometimes experiences extraordinary effects that affect the lives and economic circumstances of its inhabitants. Historically, floods and droughts have been the most frequent harsh atmospheric phenomena in the Mediterranean area. And these have forced humans to adapt their activities and urban centers to these extreme climate conditions. According to the climate researcher Jorge Orfina, climate in the future and in the current context of a global warming is only going to increase the uncertainty about the weather condition and the frequency of the extreme weather condition. The adaptation of to the extreme weather condition is particularly important in urban areas when vulnerability is higher. So in this image, you can see two flooding events in the past years in Benidorm. One of them happened in 2017. In Benidorm, there are several ravines that normally are right, but when there is a strong rainfall, sometimes cause a hard flooding in the city. We can see the flooding model in this image. On the other hand, the Mediterranean region suffered strong droughts periods. In 1976, you can see in the left image, the main water reservoir near to Benidorm was empty, and there was no water to supply it to the distribution system for many days. Finally, the water was supplied by a boat from the sea to the tanks. Here you can see the boat in the left image. And this event caused a lot of damage to the tourist image of Benidorm. Nowadays, Benidorm has a multiple water resource in case the two main water reservoirs are empty. So the city could be supplied from a nearby desalination plant, but we don't know what will happen in the future. So to understand and analyze how these adverse atmospheric phenomena will affect the city, a diagnosis of the resilience of the urban system has been carried out with the objective of determining the resilient state of the critical structure and services. The diagnosis of the resilience of a municipality is a complex process that involves the acquisition a lot of information about the urban system performance and the most critical services of the city. The scope of the diagnosis of the urban resilience in Benidorm includes analysis of 53 services that belongs to different areas that health, social, power, water, mobility, environment, energy, waste, emergency, and telecommunication. In total, 53 services. And we have into account, we include 228 infrastructure that belongs to these 53 services, all the hospital, all the electric power transformer stations, water tanks, all the critical infrastructure you can imagine in that involves to a city. So here you can see in this image, you can see the location of this infrastructure in his map. And the interdependencies between this infrastructure and services were defined in a workshop with the technician of the main services. We define in this workshop how a fail in a determined infrastructure or services will affect the other's infrastructure. Once the resilient state has been evaluated, a few impacts have been simulated, like a flood produced by a thermal inversion during 8 hours, or a drought that will produce 2 days without the main water supply resource. We simulate other impacts, like can be a forest fire, a heat wave, a cyber attack telecommunication network, or an attack against energy supply system, etc. So once this simulate, the result of this simulate, we can evaluate the cascada effect. Once the impact has been taken into account, the interdependencies and the interdependencies have been defined. A cascada effect can be analyzed in a period of time. So we can see what will happen when in this case, the water resource fails. So which infrastructure and service will be affected. So it's very important because we know when and which infrastructure will be affected. So we have take an action to prevent these events. So for finally my points, the question is the global warming the effects of the global warming are here. So the adaptation of these extreme weather conditions is particularly important in the urban areas, as we say, as says Jorge Alcina. And this urban resilience diagnosis allow to simulate how the critical services and infrastructures could be affected by an impact. And the results of these simulations we allow to the municipality to take actions for adapting to these extreme weather conditions and to improve the city resilience. So this is my conclusion. Thank you a lot. If you have any question, please don't hesitate to make me. It's all. Xavier, thanks.
Thank you so much, Miguel. So at the end, I'm sure that the audience will have a lot of comments for your applied presentation in the case of Benidorm. So now it's turn for moving to the next presentation, which will be carried out by Mrs. Amaya Celaya. And the presentation is entitled Assessing Water-Related Challenges in the Wider Resilient Context, Lessons from Asuncion in Paraguay. Amaya, is EC expert in ACE 2020 and Urban Innovation Actions programs related to nature-based solutions and resilience since 2015. And she has worked in urban environments within the 5 continents. And since 2016, she coordinates as consultant the technical work of the United Nations City Resilience Global Program. So it is a real honor to have Mrs. Celaya among us today for hearing about the work she has carried out in Paraguay. So please, Mrs. Celaya, the floor is yours.
Thanks, Xavier. I am sharing screen. Do you see my screen? Everything is fine?
Yes.
Yeah, everything is okay.
As Xavier was proposing, I am going to explain challenges found in Asuncion as for cycle water management analysis and further diagnosis. My presentation is going to be a bit more, it's not going to enter in technical details. I have to explain before that this project that that has been undertaken by the CRPT, the City Resilience Profiling Tool from UN Habitat within the City Resilience Global Program, had the support of the European Commission. And even though I'm going to explain Paraguay's example, we were working in 4 cities, Asuncion in Paraguay, you can see it here, Dakar in Senegal, Maputo, and Port Vila in Vanuatu. You can see also in the screen that the program works in many cities within the world. Our understanding of urban resilience is a bit broader, even if I know that the angle here is about climate resilience and specifically talking about water. Our understanding of resilience is, as I was explaining, a bit broader. So we understand resilience as a concept that has to do also with social action, humanitarian action, climate action, and socioeconomic recovery, no more than ever in the context of COVID. And you have there in the screen the words of our Secretary General talking about the resilience as a nexus between the humanitarian and development worlds. What a resilient city is, a resilient city has to have a plan. And a resilient city is a city that acts and is prepared to respond to hazards that in our case, we name them as shocks and stresses. I will explain a bit later on. And of course, as a United Nations agency working in urban settings, we have an holistic approach and we have an approach that is people-centered. The challenges, rapid growth of cities, climate change, of course, everything that has to do with capacities and commitment from stakeholders, and now we should add the COVID. Commitments, well, all our analysis and diagnosis, of course, are aligned with the Sustainable Development Goals, New Urban Agenda, climate agreements, Sendai framework that has to do with risk reduction, and we need also to add everything that has to do with humanitarian insights and the need for finance in the case of emerging countries more than the others. Urban resilience is for us a capacity that should be measurable. I am going to explain some of our analysis, and of course we are working with indicators, so we have to measure this capacity. We have a systemic approach, so everything is related. You will see in our diagnosis that even if I'm going to explain some details about water, our diagnosis is a bit broader than the physical side. We are talking about inhabitants and not only citizens, and this makes the difference. And of course, resilience has to do with maintenance of continuity of all the systems and all the functionalities of the city, and has to do also with the concept of sustainable transformation. We have 6 main characteristics that are grouped with the what and with the how: persistent, adaptable, inclusive, integrated, reflexive, and transformative. If you have, if you are interested in more details, you can the CRPT guide in your that I can pass to you the links with the information that you have more details, but I have no time to enter in all the details. Urban resilience dimensions, which means that we are going to be focusing the essentials, in this case processes, assets, and of course people. And I like also to explain that we don't do plans, we don't do indexes, and we don't make comparisons. So what I am going to explain about water in the part of the program that has to do with technical cooperation with cities, even if we also have advocacy and knowledge, it's specifically focused in the technical side. Our work with the cities, once we have run the analysis, has a final submission of a report, CRPT databases, because everything that we measure is based in data. In the case of Asuncion, we also worked with spatial databases, and we proposed also a visual platform for the city. What do we analyze? We analyze the what, as we call it. So we go through all the urban elements that you can see in the screen. In our case, built environment. In the case of water, very important supply chain and logistics and basic infrastructure, mobility, municipal public services, social inclusion and protection, economy, and ecology. And also we take into consideration cross-cutting issues as informality. In Asuncion, near the river, we have some settlements that are informal. Port infrastructure, specifically near the rivers and in the basins, the problem with access to land, with gender equity and equality, efficiency in the use of resources, human rights, climate action, and humanitarian action. You can see in the case of Asuncion, our visuals platform, with the amount of data we could gather. We gather around 70% of data between complete and alternative data. When we have not the exact answer, we try to find another answer that fits the questions we are asking for with regards to indicators. And you can see there the kind of traffic light analysis, generally speaking, with the red, green, and all the analysis that we had to carry out from a qualitative way. We also analyze the who, which means that we take into consideration who is working in resilience in the city. Government for sure, because local government is our counterpart in the analysis, but of course also private sector, academy, civil society, that in Asuncion is quite active, and major institutions, etc. In the visuals platform, we have a map of stakeholders, which means that it's not a list, it's a map. So we really try to see how these stakeholders are related among them, to try to understand how to work with them towards resilience. And why we are working in Asuncion and assessing water issues, because Asuncion has shocks, stresses, and challenges, is suffering from different threats that are either internal. So once we carried out all the analysis through the urban elements, we find that we have some chronic and ongoing dynamic pressures that are internal to the city. In this case, specific stresses found in Asuncion, you can see in the screen, had to do with water. You see there, the first one, had to do with inefficient mobility, with lack of implementation of policies, plans, and initiatives. And this is the reason why we propose certain measures at the end of the presentation. Energy, social protection and prevention, and inefficient solid waste management. When it comes to threats, it's not only about internal dysfunctionalities, we have also external threats to the city. And in this case, you can see that most of them are related with water, because you have there river floods, pluvial floods, storms, and solid waste and water pollution, and also dengue, that are not surprisingly shocks that are that come worse when floods and storms come. So we try to combine the shocks and stresses analysis, how to work with stakeholders. We of course include in the analysis everything that has to do with climate trends. In this case, helped and supported by Lobelia. And we went through some indicators from satellite information, and our key messages as for climate change in Asuncion tell us that Asuncion is going to be hotter and hotter every time, specifically at nights, that the heat island and the heat waves are going to be harder every time. And of course, we already know with the shocks analysis that storms and floods are also to be more frequent. So all together put us in a quite difficult situation. And to the internal dysfunctionalities and the external threats, we have to add, in the case of Asuncion, some conditions or preconditions that we find in the city. Some problems with human resource management in the local governments and public administrations, the lack of data and the lack of data management, issues with metropolitan areas governance, difficulties in, or sometimes not clear relations with the central government, and the extreme difficulties to enforce law, because they have laws, but sometimes they cannot apply them. We work through a kind of systemic approach, as I was explaining, trying to connect all these dots, and through this kind of analysis that come from software, but of course from our experts, in this case Maria Boiga's expert, who was the one running this final report with the solutions or proposed solutions for Asuncion. We found that Asuncion had three big matters of concern. One, of course, is water. Second is pendulum movement, and that is a specific issue that has to do with mobility, and the lack of economy promotion from the city council in the city. So we have these big matters of concern, and then within the spatial area of the city, we found three areas of opportunity. You can see there in yellow, you have the basins. So we have almost 19 streams going through the Paraguay River. We have also the watershed north and south, Los Bañados, that are flooded or flooding areas. And we have the historic center. So we have to work with these three matters of concern, and with these three spatial areas we find that have some issues in the city. I will focus only now in water. I don't want to forget that, of course, all our analysis and diagnosis goes through the new urban agenda, because we are working from UN Habitat. So we must take into consideration everything that has to do with planning and design, with laws, policies, plans, initiatives already ongoing in the city. And this is the reason why we don't do a new plan. We build upon the plans they have. Economy, local implementation, and urban policy. So if you see there about the basins, we propose 10 actions. About the watershed, we propose 15 actions. And in the historical center, we propose 13 actions. I am not going to enter in detail, but again, in the Urban Hub, you have the report complete. So you can go through all the details if you are interested in. Water is, sorry. Okay, it's a pre-existence in the city, and the problem is that the city had not taken into consideration ever the water, but as an accident, as many cities. So what we propose is to redraw and to rethink the city from the water understanding. This is mainly the main idea of all the actions that we are proposing. So we must take into consideration the river, the basins, and when it comes to the historical center and areas of expansion of the city, we need to carry out good sanitation and water management, of course, infrastructures and systems. So in the coastal strip, so the watershed north and south, they are already working with in building and reaching the 64 meters high code, because this is the code in which the terrains are not going to be flooded anymore. So they are already working on it, and it's perfect. Only that we found that in the project that they had, there were some details as for infrastructure, database, and social measures to be undertaken. Also, some problems with the density of the proposals they were doing as for building, and we enter in this kind of details to support this project that is already working in the city. As for the basins, we, as I was explaining, demanded them please to reorient the way in which they are treating the basins, because now are a forgotten part of the city, full of waste and with vulnerable people in the surroundings. They ran a first pilot with one of the basins, with one of the streams, that is La Cuenca y su gente in Spanish, so the basin and the people. And they began a project that is not only trying to regenerate physically the basin, but also working with people and proposing some economy possibilities with the recycling of the waste that is now in the streams and so on. And,
Amaya, you have 3 minutes more or less.
Yeah, I don't need more. Thanks. And well, 3 areas to work in water, as I was explaining, are basins, watersheds, and also the historic center, in which we focus specifically in water and sanitation infrastructures that are not working well now in the city. Just to finish my presentation, I was proposing again for you to read if you are interested in the report that you can find in our hub, and that between disaster risk reduction and sustainability, if we get some resilience, we will find some solutions for the city nowadays. So that's it. Thanks.
Thank you very much, Mrs. Celaya, for your clear presentation and for this detailed example on the application of not only a tool, but also, in my mind, a very interesting approach on involving stakeholders, that practically 90 stakeholders involved during the study in Asuncion. So let's move to the fourth presentation for today's session, which is about modeling future water availability for the city of Barcelona, that will be undertaken by Mr. Edwar Andres Forero. Mr. Forero has an academic background in water engineering, hydroinformatics, and applied and computational physics and data science. For 10 years, he has focused on modeling and design of urban water systems, urban resilience, flood risk, and mitigation. So let me express that Mr. Forero has been working in Zetacua, so same company as myself. So it is even more a great honor to introduce him and let the floor for you, Edward.
Thank you so much, Xavi. Hello, everyone. I'm Edwar Forero, and I will share my screen, okay? This research was possible with the assistance from Zetacua, Eduardo Martinez, and Robert Monjo from the Climate Research Foundation. The RESCUE project focuses on how climate change estimates to affect all spheres of human activity in the natural environment, including water resources on urban areas. Defined as a shortage in rainfall over an extended period, drought affects both human activities and the environmental balance. A significant proportion of the human population is currently experiencing the restrictions on access to drinking water due to drought effects. So globally, the drinking water requirement for cities, as in the case of Barcelona, has increased due to rapid population growth in cities, population of water sources, stress on groundwater sources, and the impact especially of extreme weather conditions. The researchers conclude that drought events will be intense due to lower rainfall and higher evapotranspiration in some areas of Europe, especially in Spain. Therefore, understanding the complexity of drought events is essential for the city of Barcelona in facing the next century associated with rainfall shortage. Well, okay. Increases in drought events, frequency and severity are forecast under the impact of climate change. Well, examples include events in China, East Africa, in the United States, in Australia, and in Catalonia, Spain. As you can see in the newspapers, the water resources availability shortage threatens urban areas due to factors as lack of climate change adaptation policies and repeated drought events. Our research aim is broadening future drought events knowledge considering climate change impacts. We define the design and implementation of a model for water amounts reservoir balance at a month scale, analyzing basin rainfall. We applied some hydrological models with the multivariate periodic autoregressive stochastic model based on almost 70 years of historical monthly flow contribution series and comparing them with the generated synthetic series for a 500 years return period. After the historical model calibration and validation process, we obtained rainfall projections using 9 Earth system models and 2 representative concentration pathways scenarios, the RCP 4.5 and the RCP 8.5. Then we integrated these rainfall outputs within the hydrological model to simulate reservoir volumes as watershed responses, developing 30 different storage patterns. The outcomes of the models were analyzed to get average trends and extreme values for each scenario in order to estimate a single water availability trend for Barcelona's reservoirs. This to understand and analyze the water resource availability in Barcelona in the near future under different climate change situations. Here we have the study area, the Llobregat and Ter rivers supply the Barcelona metropolitan area with drinking water. Llobregat River provides about 38%, and the Ter River supplies 55% of raw water for water drinking treatment plants for Barcelona. Something special is about these basins. A seasonal rainfall variability phenomenon in the two river basins led to water demand supply fluctuations. Despite this infrastructure, water resource management is complex and involves groundwater extraction from aquifers and seawater desalination in extraordinary drought events. The research data was from three main sources. The first one is the downscale climate model outputs. These local time series are outputs from a statistical downscaling method. Data include local simulations of 9 CNAP5 models under both historical experiments and future projections using RCP 4.5 and RCP 8.5. The rainfall and temperature records were from the Spanish Meteorological State Agency, considering all available stations. 44 weather stations provide Ter Basin rainfall records, and 11 weather stations contribute Llobregat Basin records. The calibration of the HBB hydrological model discharge results uses data from these streaming gauging stations of the EACA, the Catalonian Agency for Water, managed upper basins. The calibration and validation process work with two temperature stations data, where the required data for computing the evapotranspiration was available. Over the Llobregat's temperature stations, we applied a correction to the dataset. In order to measure the efficiency of the correction, we compute the mean square error for the evapotranspiration. The water volume contributions were checked for each season. The figure at your right shows how response hydrograph performs a good base flow simulation, but decrease accuracy in peak flow simulations. As results, model trends and extreme values were plotted to represent the magnitude of future situations and to consider all the possible climate model variables evolution during the 21st century. An implication of this negative trend, as for the RCP 8.5 in the reservoir system, is the possibility that a long-term alternative resource will be necessary to preserve the reservoir equilibrium. This figure displays the intercorrelations of the 9 performed models, providing a behavior trend line of the reservoir system water volume. As a result, an average trend of this model outputs forecasts an 11.1% decrease in the system water availability, applying the RCP 8.5 scenario for the year 2000. Our approach in this research also explored the water availability of the principal sources, providing about 92% of contemporary water demand. Such water availability variations will have city-scale consequences for socio-economic conditions and ecosystems. Due to practical constraints, a full discussion of adaptation measures coping with water availability shortage, as it happens in Barcelona, lies beyond the scope of this research, but we can relate an increase in alternative water resources and a decrease in drinking water consumption, such as the planning and implementation of water reclamation and reuse, desalination, also increasing groundwater extraction, and finally decreasing consumption. However, these solutions have significant technical, legal, political, and even economic issues. Thank you so much. Those are my contact details, and come back to you, Xavier.
Thank you very much, Edward, for your presentation. So very interesting to see how the system has been modeled in Barcelona, and then how solutions can be, let's say, at least analyzed together or one by one to reduce the risk for resilience in this very big city. So now let's move to the last presentation of the session. Will be about multi-temporal built-up grids on Brazilian cities, how trends and dynamic modeling could help on resilience challenges. The presentation will be undertaken by Mrs. Iana Rufino. Iana is a full professor at the Federal University of Campina Grande in Brazil, and she was an academic visitor at the Center for Water Systems at the University of Exeter in the United Kingdom from 2019 to 2020. So please, Iana, proceed with your presentation.
Thank you, Javier. Let me share my screen. Can you see my screen?
Yeah, sure, it can be seen correctly.
It's okay. So good morning. I'm very glad to be here today, and I just need to move some window here. And I have this opportunity to share with you a bit of my research. It's a part of a great effort to use cellular automata and spatial analysis for predictive scenarios in Brazilian semi-arid regions. And I want to share with you some problems in Brazilian semi-arid cities, and I'm developing this research in partnership with my university in Brazil, Universidade Federal de Campina Grande, and the University of Exeter, where I was an academic visitor when I submit the abstract to this event. First, I want to show you some Brazilian context. The northeastern Brazilian region has been vulnerable to weather extremes, especially droughts, for centuries. A combination of natural climate variability, most of the area is a semi-arid, and water governance problems increase the impacts of extreme events in the region, especially in urban areas. We have intermittent water supply and long water rationing periods due to the low level in reservoirs, create a naturally resilient environment. People often have to change their consumption behavior, converting the crisis in an opportunity of resilience increasing. Drivers such as climate change and urban growth make a very well-known drought scenario for many natural resilient cities even more difficult. Cities can be resilient to external shocks and crises for a long time. Like in my city, we stay many years dealing with droughts and rationing periods. That may help turn crises into opportunities for development. The consequence of insufficient water supply lead to a cycle whereby increasing urbanization increases pressures for the water, especially for water demands, which is aggravated by a poorly urban planned environment. Built-up legislation in Brazilian cities usually does not consider water resources issues or even environmental issues. So the land use and occupation planning and permits like master plans do not take into account the pressure it imposes on water resources. So we have here in Northeast a natural climate variability, a linear dependence of rainy seasons with a predominance of surface water as the primary water drink source. And we also have a low preparedness for weather extreme as droughts, even knowing it's a natural condition of the region. And in this context, this work tries investigates future growth trends as a useful tool for hazard mitigation planning and sustainable development, estimating future water demands, droughts, using a set of very often exposed cities to water shortage in the Northeast Brazilian region. As you can see in this slide, we have this region, let me point it with a laser pen. We have some areas. This image is from 4 days ago. And even now, we are not in a drought period. We have lots of reservoirs with low volume, and this is represented by red and orange colors here. So we choose 6 cities in this region, and I will show to you our first results. Our main question is how trends and dynamic modeling could help on resilience challenges. In order to answer these questions, we are using the global human settlement layer. I believe most of you knows this project and this global database. These projects produce new global spatial information, evidence-based analytics and knowledge describing the human presence on Earth. The GHSL operates in a fully open and free data and methods access policy, and the analysis of the Northeastern Brazilian cities raises more significant challenges because we have no data. So when you have a global database like GHSL, we have almost no data. Let me correct my rephrasing. So those global databases help us a lot to have input data for our models. And for the Northeast part of Brazil, it's very, very useful, a lot of useful. In this sense, free available remote sense data with the quality of GHSL database is a perfect opportunity to calibrate a predictive model for future scenarios. The built-up grids, I am using the built-up data from GHSL, represent the first multi-temporal explicit description of the evolution of built-up presence in the Earth since 1975. In this work, the GHSL built-up grids for select Brazilian cities are used to generate urban models using GIS technologies and cellular automata for spatial pattern simulations of urban growth. The main goal is to improve water security in those cities using dynamic modeling to help the city to deal with the resilience challenges. We are using a prototype cellular automata land use model built in R package called Simlander. Simlander stands for Simulation of Land Use Change using R. In the cellular automata is a discrete dynamic system in which space is divided into regular spatial cells where time progresses in discrete steps. And let me show you some of those steps. This is a graphical synthesis of the methodology we are applying. The state of a cell can change in according to transition rules, which are defined in terms of neighborhood functions. The transition rules determine when and for what reasons the state of the cell changes for quantitative or qualitative reasons. The transition rules are descriptive alternatives for explaining the difference in each cell caused by some neighborhood influence. The overall design of the modeling procedures includes some steps. The first step prepares the GHSL data to be used as an input in the Simlander model. The second step is to establish the variables and to generate the influence factors based on previous assumptions. Is the more complex step because we need to make some assumptions about the neighborhood influence. And in this step, the transition rules are defined and tested. Once all variables are processed, the third step corresponds to calibration procedures. which initiate using a baseline timestamp and a final timestamp to make the model run and achieve the best accuracy using a comparison between the simulate data and the input data, which is the GSL data. Finally, after many runs, the best accuracy defines the general transition rule for the whole model in an equation, and you can now simulate for the future. And this is the time we are trying to simulate now, 2017 to 2040. We already have all those scenarios simulated, and we are analyzing the trend analysis and doing trend analysis, water demand estimates, and urban planning applications. The main challenge for calibration is the selection of the change drivers and the understanding of the spatial behavior along the time. All the explanatory variables are generated using the 30 meters spatial resolution to match the resolution of the Landsat-based scenarios from GHSL. For the future scenarios after 2016 and with no reference data to compare, the predicted accuracy is calculated using linear regression based on the values already registered. This is some results from the 6 cities. The more precise the information, the better will be the outcome for a better preparedness. Similarly, disaster risk models rely on the same exposure variables with the difference that they may need to take into account also the expanding settlements in the coming age. These are some of the reasons why it's so important to have accessible, homogeneous, and free data on settlements. In this slide, you can see our first results, and we still are doing simulations for other cities. Those cities are often exposed to water shortage and ration periods. We only simulated cities over 50,000 inhabitants in this work, and there is cities around 300,000 inhabitants like Caruaru, and 400,000 inhabitants like Campina Grande, and over 2 million inhabitants like Fortaleza, which all those cities faces critical water shortage and times during drought periods. Even with high accuracy, we are trying to refine the model to solve some urban growth complexity, like in filling, when the increase in population density in the existing urban area, edge expansion, urbanization advancing from the edges of an existing urban area, and the outline when you have emergency of new urban patches that are isolated from existing urban areas, some islands outside of the urban area. That is a current simulation, a challenge for this work, I think. That shows some graphs. This graph shows that similar cities which match in population and area can show different trends on simulations. Our goal now is to analyze and evaluate how those future built-up scenarios can help on water security plans for those cities or similar ones. Here you can see Campina Grande in Caruaru. They have a similar size and population, but completely different trends in our simulations. There are many studies relating to the growing population or growing density with water demands increase and estimates. And we think that predictive models of urban growth can add the spatial component to those estimates once it's possible to visualize the built-up growing or impervious increase. We have another group working with impervious rates we can extract from those results and make cross-related analysis with population density standards. I want to thank the audience and attention, and I'm available to clarify any issue at the end of the session. Thanks.
Many thanks, Iana, for your presentation. By compiling the results that you have obtained in several Brazilian cities. So as you've seen, we have done the 5 presentations right now. So many thanks to all the speakers for your high-grade works and for the clear explanations given to the audience. I'm sure that we have all acquired a global picture about the important challenges that water sector is facing in terms of climate change, as well as about the potential resilient solutions that could be implemented to fight against and adapt to it at serious scale. So now we have around 15 minutes for question and answer. So we'll start by posing the questions which are particular for each presentation. And at the end, we will have, I guess, some time for launching a very short debate among all the participants in this session. So the first question goes to Mr. Balaguer. And the question from the audience is, how will your comprehensive resilience diagnosis be put in practice? Is all this complex information manageable and usable for first responders, for example?
Yeah, thank you for your question. Of course, yes, we find that we in Benidorm they have to solve some problems. They have to start some infrastructure to make a redundancy, and we are in the next step. So the municipality that he is the first responder, we can say, has access to these results. And of course, the next steps will be probably to connect the sensors and to that will be able to do a real control and using the Internet of Things. The responders, and we have this data. So, but the first step we did here in Benidorm is the diagnosis. And in the future, we can, it will improve. So thank you.
Thank you very much, Miguel. So just to complement on the question put by the audience, so you have, let's say, several services for, let's say, increasing resilience in cities, isn't it?
Yeah, yes, for sure. For example, in the water supply system with the tech, we need to build many more tanks to have more amount of water in case the water resource fails. So, and another topics too.
Okay, thank you so much for your answer. So let's move to another question. This question is for Mrs. Amaya Celaya. So the work you have explained has been focusing in water, and in fact, you've done a clear presentation on how your, let's say, your methodology from UN Habitat is working and how to use the tool that you are employing for analyzing, let's say, somehow resilience status in a city. But you have focused your presentation on the water vector as it was the core of this session. But can other vectors like energy or transport and so on be considered by using your methodology and tools?
Yes, of course. As I explained in the presentation, main three matters of concern that we decided to focus in, because there are a lot, but we from the program have a clear understanding that it's better to go to the essentials to get something done. So the main aim of our work, of the tool, program, etc., is get some actions. And for this, we think that it's better to go for few matters of concern, really act on them, and then go further. Because if not, we end by having a never-ending list of actions or proposals, and we have not a final, real, and I would say not early, but immediate action. So yes, okay. Three matters of concern were water, but we had also economy. As for economy in Asuncion, Asuncion shares this problem with other capitals. There they were, shall we say, provision places, but they are not it anymore. So they keep being capitals of the countries, but they have no industry. They have not services fabric in the urban grid. So economy somehow is something that was there, but it's not here anymore. So some of our proposals were focused in promoting within the city council, not the country, but the local government and the city itself, some economic measures going for circular economy and decentralization. And it links with the third matter of concern, that was mobility. Something, well, the key measures for this issue in the city is that they were trying to work with more buses, more train lines, more even metros to solve mobility problem they have in the city. We found that the pendulum movement was the problem. So proposing more bus lines was not going to solve the problem. The problem was going to be solved by decentralize the way in which people sleep, work, and live. That's it.
Okay, that's clear. So let's say that apart from water, you are also dealing with all the pillars of the circular economy or even ecological models in cities and in regions. That's clear. Thank you, Amaya. So next question goes for Mr. Ahilan. And the question is that all the systems you consider in the in this study deliver water saving benefits as you exposed. And you also said that dual modes of resilience indicate that distributed catchment scale rainwater management can deliver multifunctional and multi-benefit systems. The question is, at which implementation level are these, let's say, solutions nowadays in the region you studied in your work?
Yeah, currently in this case, we are considering all of the houses plan to install the different, it's a hypothetical situation we are considering at the moment, but again, the decision to implement is up to the residents as well as the local council. And also the water companies, if they also provide some kind of incentives to the householders because of we are going to reduce the amount of water consumption as well as the amount of water get into the wastewater system. So if they provide some kind of incentives to the householders, so they should be able to roll out into the implementation. This study is mainly as a hypothetical situation we are considering. If we install this sort of system, what could be the benefit on the flood resilience as well as the water supply augmentation. So it's currently is on the early stage, not in the installation phase.
That's clear. So let's say that you are about to convince and define the incentives in the regions to implement it and go for a real application. So let's expect that in a very short time we can read or at least see that everything is going on with the implementation of the solutions you detected during your work. Thank you for the answer. So we have another question for Iana. So if you can be very precise in your response, is that you said that a closer relationship between urban planners and water managers should help on land use planning actions and policies for water scarcity, as well as for improve the resilience of the cities. So how would you ensure that it really occurs in the real world, let's say?
In the real world, we think that the water permits and the land use permits, so the legislations about how can you occupy the land and how can you use the water for this land, have to be planned and written together. People need to have some interaction before the laws become a regulation. And then at least here in the Northeast, we have master plans, land use regulations, and water plans completed apart. They don't have connections. So we can see clearly that if you could like suggest that some areas in the city you cannot use for this use because if it will be a lot of pressures and water demands, you have a area very densely. So people are not doing this kind of things together. And in the real world, my answer is we researchers needs to provide this information, trends, future scenarios, results, and analysis to make the people that are writing laws and legislation to make better laws, better water permits, better land use permits for our cities.
That's clear. Thank you very much for your response, Iana. And finally, let's move to the last question that goes to Mr. Edward Forero, and is that you have mentioned that reuse could reduce water availability risk by around 50%. Optimization actions would achieve around 77% reduction in risk, and total depletion of risk of water availability if water conveyance was deployed. These are, of course, technical or technological solutions for managing risk of water availability. But have you also considered environmental, economic, and governance factors for each one of these solutions? Identify and how?
Thank you, Xavi. Yes, indeed, we also consider these environmental and sociological impacts of each solution. Well, in fact, for example, this conveyance of water solution is technically possible, but economically speaking, it's not possible. But for example, the reduction of the water consumption in Barcelona's area is something that, politically speaking, might be really positive, but sociologically speaking, is hard to embrace into the population.
Okay, clear. So now we'll have more or less sorry, just 1 minute. Great. So we'll just have 5 minutes more for having a debate. So this is just a global debate among all the presenters. So please start after the my exposition to start sharing your opinions, and I will try to give your turns when possible. So as you know, society is being hardly affected nowadays by a sanitary crisis, which is running together with the climate crisis, which is the main focus of our conference. Therefore, there's stress on society, economy, and environment. So this is a reality, and probably in the future we will continue with the impact unless changes in production and consumption models are implemented. On the other sense, as you know, governments are starting defining green, digital, and fair recovery, transition, and resilience programs at several scales, let's say at continent scale, countries, regions, cities, and so on. So the question of the debate today is that, as experts in water resilience, do you think that these programs may help increase cities' resilience? And if yes, which are the main factors that need to be considered to ensure the success?
Xavi, can you repeat the question, please?
Yes, Xavier, we don't hear you.
Sorry, I will repeat. I will repeat the question. Can you hear me now?
Yeah.
Yes.
Okay. So the question is that as experts in water resilience, do you think that programs on green digital and green recovery may help increase cities' resilience in reality? And which are the main factors that need to be addressed to ensure the success of these plans?
So may I start on that?
Yeah.
Yeah, so thank you for your question. Actually, we recently did the study in what is the main barriers in the adaptation of the green infrastructure in the urban cities, and then we consider a range of the technical aspects as well as the public perception point of view, and then we realized that public perception is the main thing we need to overcome if you want to successfully implement the green infrastructure. Particularly, they need to take ownership, and then they need to maintain the infrastructure if you want to access get the long-term benefits. So this is the study we did in Portland, Oregon. So that's the main conclusion we have come up from that study.
Clear. So is there any other opinion between the panelists?
I agree with Mr. Ahilan. For example, in Barcelona's case, since 1997, there has undergone a revitalization process on the basins of this region in Catalonia. But this process has an impact directly the urban resilience in Barcelona. So there is a mix between the impact of the real these green solutions and the real impact that it has into the urban resilience.
We have time for one more answer.
From my side, of course, taking into consideration that we are talking mainly about the infrastructure and that we need resources to run and to be able to develop this infrastructure, there are a couple of things that we have to take into consideration that are involving people. So governance and stakeholders' commitment and engagement when it comes to institutions. So working with people, because institutions are made for people, from people, and working for people. So involving institutions and all the actors needed and working for the citizens, so the inhabitants of the urban.
And Amaya, do you think that just by linking to your comment, do you think that maybe having some cross countries cooperation or learning issues about experiences and how to apply it in other countries could help advance in this sense?
Absolutely. I am myself, I am very lucky working with many different countries and cities. We usually used to work in silos and used to go for as maximum regional understanding of common sharing problems within cities. But now we can see clearly that cities share problems all over, and water is one of them. So of course, peer learning between cities, it's super interesting, and it's even more interesting, I think, that learning from experts or from institutions. So it's city to city learning. I did so, it's working for me. Let's go to see if it works in your situation.
Okay, thank you very much. So with your sentence, we will close this session. So I deeply acknowledge our 5 panelists and all the audience for the high-level work shared today, as well as for the very interesting discussion that we have established during the question and answers, and also in this very small final chapter on open discussion. I wish that some of the experience shared today in this session can be applied in a very near future at real scale and serve to increase water services resilience and therefore contribute to enhance sustainability in our cities and, as Amaya said, in our lives. So to close the session, I would like to share with you a sentence that I usually repeat to myself in case it may inspire you somehow. A sustainable and livable future is everyone's dream, but acting right now in favor of the planet and humans is the unique way to achieve it. So let's start, please. So remember that you are now invited to attend the closing session, which is happening in the plenary room right now after our session. So this way you will be able to participate in the global wrap up of this interesting conference. Again, thank you very much for your kind participation.
Too much, Javi.
Thank you.
Thank you. Thank you. Bye-bye.
Bye.
Thanks. Bye.